You maybe remember me from the previous talk, from 1 billion years to 1 second. And basically, this is the last slide, and I wanted to go through it a little bit. These are basically a set of quotes by Donald Knuth. And I want to go a bit into the detail because he's quoted quite often, but I think that they only take a very short part of the quote, and it actually loses the main part of the meaning. So all these quotes are taken from this paper from 1974, named Structured Programming with Go-To Statements. So go-to statements may not be very modern, but some of the things he says, I think they are truths that are still valid today. So if we go on the first one, for example, here it says, programmers waste enormous amounts of time thinking about or worrying about the speed of non-critical parts of their programs. And these attempts at efficiency actually have a strong negative impact when debugging and maintenance are considered. We should forget about small inefficiencies, say about 97% of the time. Premature optimization is the root of all evil, and this is the part that's always quoted. Yet we should not pass up our opportunities in that critical 3%. So I think that Donald Knuth, with this part of the code, says that one should not start optimizing if the code is not done. But for example, some optimizations would be related with having like a good design of the data structures. They make sense. So for example, one of the optimizations I show, finishing up a loop early, if we know that all the other iterations are going to be false. I think this is one of the 3% of the optimizations that could be applied because the additional complexity, I think, is quite small, and it actually make even the code easier to understand. But some of the other non-obvious ones, like memoization or replacing operations, these ones should probably be done only after we are sure that optimization should be applied. The second one from the same paper on the same page, it says, it is often a mistake to make a priori judgments about what parts of a program are really critical. This is why I asked people to imagine or try to estimate how fast an optimization would be. I think that none of you was 100% accurate, so this should make it really obvious that what we sometimes believe it's going to be faster or slower is not really true. And the sure way to know is to measure on the appropriate hardware. And last but not least, here I have another quote, which he says, in established engineering disciplines, a 12% improvement easily obtained is never considered marginal, and I believe the same viewpoint should prevail in software engineering. Well, just to prove that I'm not a Knuth fanboy, here I would disagree a little bit, because I think that software and computer in general are slightly different than the other kinds of engineering, because there is one thing named Moore's Law that has been valid at least for the last 50 years. And basically, every 2 years or so, the capacity of computational power of a computer gets duplicated. So in these areas, maybe a 12% seems really marginal and not worth it, because one could just wait a couple of years and have a much more faster computer. But actually, if we move to page number 9, we see that this quote is longer. So in this longer quote, I would agree. So basically, what Knuth adds, which is not included here, is that if he is writing a program that's basically a one-off, some kind of script, he would not go for this 12% improvement, because being just a one-off that's not going to be maintained or read by anybody else, this would probably be a waste of time. So his small improvements he's talking about is about some quality software that we want other people to read and contribute on. And yeah, these were the small quotes I wanted to add. In the same GitHub page as I have the presentation, there is the link if you want to read the whole paper. And with this, I think I conclude the lightning talk. Thank you very much.